Good morning, everybody. Today we're going to be doing day 2 of chapter 24. We're going to do a few problems together so that way we're good on what we need to do when we're comparing means. So again, remember this is going to be 2 means that are different groups. Okay, so let us begin. Remember on, now I'm forgetting, Wednesday, I did a video where we went over the assumptions and conditions. So let's go over the test and the intervals, and then we'll do some examples. So we have here the 2-sample t-interval equation. Again, I hope that on our AP, we won't have to write it out, but rather we can use our calculator. What I mean by that is that hopefully they won't have any reason for us to do any math on it other than doing a margin of error, which we did on Wednesday. But here's the formula. Let's see what it looks like here. So as you know, on your formula sheet, there is a one formula, which is the confidence interval. So what we're looking at here is in the parentheses is the difference between the 2 means plus or minus the degrees of freedom. Now, the degrees of freedom when we're talking about means is going to be not quite the 2 numbers. So for example, if I have one sample that is 50 people and another sample that's 75 people, the degrees of freedom is going to be some number that is kind of a combination of the 2, but is not going to be anything easy to calculate. So we definitely want to use our calculator to find the degrees of freedom for that. Let's keep going. Times the standard error. Remember, the standard error is going to be the square root of the standard deviation squared over n plus the other standard deviation squared over the other n. Okay. So let us see our example. We already know how to do this. This is the batteries problem. So I'm going to go through this and we're going to do a confidence interval for it. So let's see. So here's all the work for it. It's in the book. It's the very first page of chapter 24. Or you can see it from my page. So it says, judging from the box plot, which I grabbed from a previous slide, the generic batteries seem to have lasted about 20 minutes longer than the brand name, because what we're doing is we're doing the difference of the means, I believe. So this is around 200. This is around, this is around 205. This is 180, 190, something like that. So they're saying that it lasts about 20 minutes longer than brand names. Before we change our buying habits, should we expect to have what should we expect to happen with the next batteries we buy? In this case, the question is, how much longer might the generic batteries last? Before we begin, let's quickly go over some of the assumptions and conditions. If you recall here, we randomly picked generic batteries. He used 6 sets of AA alkaline batteries from 2 major battery manufacturers. This certainly would be random. He's just randomly buying them. If you bought them all from the same store, does Dollar Tree get different batteries than I don't know, DeChico's or ShopRite? I don't know. But choose 2 sets of batteries at random. There it is right there. So the random is right here. Okay. What else do we need to know? The less than 10% condition is not really that important for these problems. Let me just do, so it's random. Certainly it is less than 10%. And if you recall, we only, of all batteries, we only care if the sample's large or if the number on the population is really small. And in both cases, we don't have that. Nearly normal. So we can certainly see that it is slight skewing, nothing major. It's very mild skewing, nearly normal. Now, the number is only 6. So we would really need to know about the unimodal. This is a slight skewing. So let me go back to my calculator. I actually still have the data. If you wouldn't mind putting the data into stat 1, stat 2, maybe you already have it because I still had mine. So I'm going to go to stat plot. I just want to quickly look at the graphs. Stat plot on. Let's first do a histogram. Oopsie. go. And then we're going to go down to L1. So I'm going to do graph. Oh, geez. That's right. I already had data in there. Sorry. Zoom 9. The graph still might appear, but no big deal. Okay. So the way I have the graph situated in this case, certainly it's unimodal and we have skewing to the right. But interestingly enough, this was I can't recall, this was the brand name. And isn't that interesting how the skewing on the box plot is not really to the right, it's to the left. I want to see if I can just change this just a touch. The smallest number is 172, so 169. So let's do 168. And let's go to 206. They were doing it in increments of 9. I don't know. The problem is there's only 6 points. So it's really hard to do this, well at all. It's really hard to do. Let me try the window one more time. Let me try 8. See if I can get it any better. I'm doing this to show you guys this is like not easy. So we go back and change it to 9 and see whether, because I changed my X min and max, whether it changes anything. Graph. Yeah, and there it's back to that. But certainly from this, between the box plot, now interesting, let me change this to box plot. I'm just curious while I'm on the phone, making this video, sorry. And while I am just kind of saying, let's see here, let's do a box plot graph. And there's the box plot. So this is showing that skewed to the left. So, interesting that I can't get the histogram because there's only 6 points. How many buckets can I make? There's only 6 points, but it's certainly unimodal, and I can see that it's slightly skewed. So I'm going to make a note, unimodal. So nearly normal is correct. The last thing is going to be the independent groups. The generic batteries are not the same as the brand name batteries. Okay, so therefore, conditions have been met. Copy this over. The conditions were met, and we're going to be able to use the 2 sample. I made that small too. No big deal. We're going to be able to use, so conditions met, use 2 sample T interval. Okay, so let's go and make sure you have the data in your calculator. I want you guys to practice with this. At this point, we should be practicing as much as possible, get in our brain how to do it, so that when we get to the test on the 22nd, which is, oh my gosh, about 3.5 weeks away, yikes, we'll be good to go. If I was in school, I would be talking about the date coming nonstop. It's just kind of happening. It's here, but it's coming. It's like a train coming. So we're going to go to stat tests, and I'm going to go to the 2 sample T interval. Okay. I'm going to use data. L1, L2. Let's do a 95% confidence. They didn't tell us what to do. And we're going to talk about pooled on Wednesday. So I'm going to hit enter. So, I know why, because my brand name was negative. Can I switch this over? I'm going to switch my stat. I actually am going to make my L1, my first one, be the generic. So let me actually tweak this a little bit. So I want to make sure that I note what's what changes. Why am I changing this? Because the data is negative because the brand name didn't do so well, which is funny. We would think it would be the opposite, right? When we buy brand name items, we expect it to be better quality, but in this case, so now I'm going to do, rats, I messed that up. Sorry about that, guys. Stat, this is what I do. Enter, changed it, calculate. Pooling, we'll talk about on Wednesday, so no pooling right now. Okay, so we have a 2.1 to a 35.1. So let's actually make sure this is going to be, I'm going to do the first one. The first mu is going to be the generic, and the mu2 is going to be the brand name, because I'm going to use that in the next question I'm going to have in a second. So I'm doing mu1 minus mu2. Okay. So what we're doing here is we're saying that the confidence interval was 2.1 to 35.1. So what we're going to say is we are 95% confident that the true mean difference between generic and brand name batteries is between 2.1 hours and 35.1 hours longer for generic than brand name. Okay. We're 95% confident the true mean difference between generic and brand name batteries is between 2.1 hours and 35.1 hours longer for generic than brand name. Okay, good. So now let's go on to the next question, as you can imagine is going to be, before we move on, they are giving us, which we will never, ever, ever, ever have to do, but for those of you who are into numbers, which I don't think in this class I have too many people that are overly conscious of like, oh my gosh, how did we create that calculation? Here's the degrees of freedom calculation, which is why we just use the calculator for it. Okay, so I'm going to skip. I'm going to move on, but they give it to us. So the two sample t-test for means is going to be similar to what we did for two proportion. We have to find the conditions, which we just found for the battery problem. And we want to make sure they're independent groups. And here is the question. Is there evidence that generic batteries last longer than the brand name batteries? So I'm going to go back to my data. We already found the conditions. Conditions have been met. We're going to use a two sample t-test. So let's go back to stat, tests. We're going to go down to two sample t-test. You see it right there? Two sample t-test. I'm going to choose that. I'm going to choose L2 is going to be first. L1 is going to be second. I'm looking to see, is there evidence? What's the question? Is there evidence that lasts longer? Okay, so generic battery lasts longer. So I'm going to have it that it's like this. Now I'm going to do a few things. I'm going to pull this up and I'm going to then put in the rest of the data I need. Because remember, I need to do phantoms. So I've already said the brand name, the generic is going to be my mu1. This is going to be my mu2. I'm doing that. My null hypothesis is going to be that mu1 is greater than mu2. Okay. I'm then going to say that HA is going to be that mu1 is greater than mu2. You guys know. This is always equal to. Always, always, always. Please, 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 please make sure you do that. I caught myself as soon as I wrote it down. We found the conditions. Found conditions on previous page. Right? You would write all the conditions down. We're going to use, therefore, use two sample t-test. Okay, so we're going to use a two sample t-test. Let's make an alpha value, alpha level of 0.05. So now let's do the test, which I just did. I didn't look at the data. So we have a t value of a t value of 2.5. We have a p-value of 0.015, and look at this degrees of freedom. We have 8.98. Does that have any inkling ever at all between a 6 and a 6? 6 generic and 6 brand name. It doesn't. There's no way you would have calculated that on your own without plugging it into the calculator and doing a test. So I'm going to write down here my three things, 2.55. So t equals 2.55. My p-value was, I might as well write p-value, it's always good to write that, equals 0.015. And my degrees of freedom, I'm always going to write it down, was 8.9, I believe it was. Let me just make sure. Degrees of freedom was 8.98, 8.99, okay? So that's my data. I obtained my p-value. So I'm going to make a recommendation because the p-value of 0.015 is small versus the alpha level of 0.05, we reject the null is there evidence? Yes, the null hypothesis. there is strong evidence. You just repeat pretty much what the question says, almost always, 98% of the time, evidence that the generic battery lasts longer than the brand name battery. This would be a really cool thing to do for a test. So I don't know how you could make sure to, when it officially died, boom, got it. It probably would happen for me when I was sleeping or something. Anyway, I'm sure there are ways that you could do it. I just don't know off the top of my head. That's it. That's how you would do a 2-sample t-test. So let's do one together, start to finish. This is a question that was in the classwork, the book, but we're going to do it all together. So researchers wanted to see whether there's a significant difference in resting pulse rates for men and women. The data she collected are displayed in the box plot and summarized below. So we have the summary data, 20 males, 24 females. We have the mean. We have the standard deviation. And that is all we kind of need. They're giving us what some of the numbers are, what the range was. That was good, so we don't have to estimate. They're also telling us what the median is and what the IQR is. Fairly cool. What do the box plots suggest about the differences between male and female pulse rates? So this is where you're going to talk about cuss. So let me write it up here so we have room. This is where you're going to do cuss. So make sure, so think about things that you would do for the cuss. What are you going to write down for them? Certainly, let's talk about the center. Is the center any different between the two? No, the mean values are roughly equal. So I'm going to write that down. So the center, mean are about equal. We have 72.75 versus 72.625. For all intents and purposes, they're the same. The median is exactly the same. And median, exactly the same. We'll talk about unusual if we need to in a minute, but I don't see anything unusual. So let's go right to spread. The spread of male is, what did they say it was? The range is 20, while female is larger spread of 29. Spread of male is 29. Range, I'm going to write range here just so we're clear that it's not, not talking about the standard deviation. So with standard deviation and standard deviation of female is also larger at 7.7 versus male of 5.4. Yeah. Shape. The male is certainly roughly symmetric. And so is the female. That's kind of it. So I think we're good to go. I want to make sure you touch upon everything. Even though I was talking about difference, just mention everything, even if it's the same. Because as you know, comparing and contrasting, if I talk about comparing, you also want to contrast. So make sure that you have, in this case, is asking for contrasting. What's the difference? Make sure you just mention all the things. And in fact, if you wanted to say there's nothing unique about either one of them, you can even say that too, just to make sure you cover everything. When I talk about talking about a picture, I talk about cuss. Unless it's a line, and I talk about line, L-I-N-A, linear. Okay. So is it appropriate to analyze these data using the methods for inference discussed in this chapter? Explain. So let me quickly bring this smaller so we can then talk about, real quick, oh my gosh, that's small. You'll never be able to read that. Well, you'll be able to read it because I will make it bigger eventually. Or we have it in our notes, of course. Move over here. Okay. B. So we have random. We have independent groups because male are not the same as female. We have less than 10% of all males and females. And the graph is roughly symmetric. You don't have to worry about the unimodal because the number is over 15. Okay, so therefore we can use, we're jumping on to C, a 2 sample T interval. So let's talk about C, which is the confidence interval. Is it appropriate to create a 90% confidence interval for the difference in mean pulse rates? So I not only want to do the confidence interval, but please always do context, even if it doesn't say to. Okay, they won't take off points if it doesn't say to, but certainly if they expect it because that's what you should do, they will take off points. I don't want at this point. We got this. There's no reason why we shouldn't be able to do it. So let's go back to stat, go to calc, go to test, sorry. We're going to go to a 2 sample T interval. Sorry, that's a 0. Sorry, I always forget where everything is. My brain is mush. 2 sample T interval. We're going to use stats this time. Enter. So let's see here. Wow, it's crazy numbers came up, right? For me. So let's start with males. It doesn't matter. It doesn't matter. So it doesn't matter. I'm going to say it right now. I don't know what to say. I'm going to make my males my mu1. And I'm going to make my females mu2, okay? So I'm just going to do it. I'm stating it right now. If by chance I wanted to change it, I could certainly do that in the end. What did I just do? I do this all the time, and I just waste time. I could choose 0, I guess, at that point. You're all probably sitting there like, why isn't she just choosing 0? So my mean is going to be 72.75. My stat test 0. Thank you. What's happening here? 72.75. My standard deviation is 5. I'll go out all the decimals. Why not, right? 57225. The number is going to be 28. What just happened? Oh my gosh, you're like, what is wrong with her? 5, 7, 2, 2, 5. Arrow. 28. Second one. 72.625. Down. Degrees of standard deviation is 0.69987. And 24. And my confidence level is going to be 90. And again, do not worry about pooled right now. And I'm going to hit enter. Calculate. Cut. So I'm getting negative 3.0 to positive 3.3. So I get negative 3.0 to positive 3.3. So this is interesting. We are 90% confident that the true mean difference in means between male and female pulse rates is between negative 3.0 and 3.3 beats per minute. So, interesting. So I'm already trying to say that I'm seeing that there really is no difference, right? But let's answer the last question. Is there evidence that there's a difference in pulse rates between men and women? As soon as I see the word evidence, I have to do a test. So I'm going to do right now for D, D, I'm going to do a two sample t-test. As soon as I see the word evidence, even though I can use my confidence interval to do this math, let me go now to stat tests, two sample t-test, number 4, enter. All my data is there. I'm looking to see, is there a difference, right? Is there a difference? So what I'm going to do is I'm going to do that my HO is going to be that, I'm going to write it in, so that way we have mu1 is equal to mu2, and HA is going to be mu1 is not equal to mu2, okay? My alpha level is going to be 0.05, okay? So now let's do the math. I'm looking for not equal to, because it's saying, is there a difference? It's not saying greater than or less than or anything like that. Is there a difference? And this is kind of interesting because, for example, babies have really high pulse rates. Birds have really high pulse rates. So in that case, you want to know, is it higher? Is a baby's pulse rate higher than a 5-year-old, or than is a 80-year-old's pulse rate different than my pulse rate, for instance? So that would be certainly greater than or something like that. So what do we have here? We have a t-value of 0.067. We have a p-value of 0.94. We kind of knew that. And degrees of freedom is 40. Where did 40 come from? We have these numbers that are not even close to it. Again, degrees of freedom would be hard to calculate. So let's do this. It's 0.067. So what do we have here? So we have two sample t-tests. So we're going to do t equals 0.067. The p-value was equal to, equal to 0.94, something like that. And the degrees of freedom was, I can't remember right now. You guys remember? 40. This was 947. I'll do that. And this is 40. Okay? So, because p-value, and I hope by me repeating this, of 0.97 over and over and over again is large versus the alpha level of or greater than, whatever you want to write, we can fail to reject the null hypothesis. There is no evidence that the difference in pulse rates between males and females is different. Cool. And that is it. We will do a problem like this for homework tomorrow, and I will have office hours tomorrow if anyone wants to go over anything. And on Wednesday, we will do the pooling. You have a wonderful day now. Bye.